In the first lesson, we saw some basic commands about the file system, like pwd, which is print working directory, and also ls, which makes a list of a directory or one or more directories. It is listing the content of one or more directories. And then we also saw the command cd, change directory, which allowed us to move from one directory to another. In other words, to change the current directory. And we also talked about absolute paths and relative paths. An absolute path is a path that starts from the root of the file system. All the files in Linux and Unix are organized in a hierarchical manner, like a tree. There is at the top the main directory, which is called the root directory. It is denoted by this slash, and we can list the content of the root directory with this command ls slash. And then under each directory, there are some other subdirectories or files. And we can list their content like this. For example, so this is the full path to this directory, starting from the root, and then the subdirectory directly under the root directory, and then the other subdirectory under this directory, user. We also saw that there are relative paths. For example, if I am already on the directory user, I can list the content of directory bin like this, just typing bin, and it will be interpreted relative to the current directory, which is this one. So this is a relative path. A relative path does not start with a slash. Maybe it can start with dot dot and then something like this. This is again a relative path. It is relative to the current directory. It says from the current directory, go one directory above to the parent directory. This dot dot was for the parent directory, and then from the directory go down to the directory var, for example. Or let's add another in the path. So again, this is a relative path. If I can say, for example, dot bin like this. Again, this is a relative path because it says starting from the current directory, go to the directory bin. But usually it is the same as this one. It is not used frequently. It doesn't make sense. It doesn't make sense to use it like this. There are some special cases that it does make sense, but usually it doesn't make sense. Today we will continue with exploring the file system of Linux. We will see what main directories and subdirectories are in the Linux file system and what is stored in each of them. We are going to use two additional commands, which is file. The command file tells us the type of a certain file or directory. For example, if I say, for example, file bin, for example, it says that bin is a directory. Bin is a directory. If I say, for example, file bin it says that bin Tomcat is an executable. The keyword is executable. This is the type of executable. So it is an executable file. In other words, it is a command. We will see also the command less. The command less shows us the content of a text file. So if there is a text file with command less, we can view its content, and it shows its content page by page. In general, there are two types of files in Linux: binary files and text files. Text files are readable by human beings. They contain characters, letters, numbers, and things that are readable by humans. A binary file contains things that are not readable by humans. They look like garbage if we try to read them, but they can be interpreted by some other program. They can be understood by some program. Okay, so we also mentioned that we can use something like this to list. First of all, let's go to the directory root. Here we see some directories like bin, boot, dev, home, etc, etc. In the directory bin means binary. If we list the content of the directory bin, we will see that it contains mostly commands. Most of the commands are stored in this directory. There are some other directories that store commands as well. We can list all the commands that start with B, for example. So with this command, we list all the commands that start with B. Or all the files that start with B in this directory. And we see this file here, bzless. So if we do a long listing of this file, we see that this file is pointing to another file. So it is something like a link. It is a symbolic link, actually. We will see them later again in more details, symbolic links. And if we try with file bzless, this command file tells us this information about bzless. It is a symbolic link to bzmore. So it showed us, it told us the type of the file. Now, if we continue exploration further, what is bzmore? Or we can try with file bzmore. It says that bzmore is a POSIX shell script, ASCII text executable. So this ASCII text means that it is a text file. It is human readable. Executable means that it has executable permissions and it can be executed. And also this is telling us that it is a shell script. Since it is a shell script, we can view its content with less. For example, less bzmore. And it is showing us the first page of this file. And if I type spacebar, I go down to the next page. If I type again spacebar, I go down to the next page. But actually, we have reached the end of this file. And I can also move with arrows, up and down arrows. For example, if I press the up arrow, I'm moving up in the file. If I press the down arrow, I'm moving down. So I can move either by pages or by line. Also, if I press enter, it goes down one by one, one line by one line. To exit from the command list, I type Q at the prompt. Now let's check another file. Bash. So we are in the directory bin, which contains commands, and here we have this command bin bash, which is actually the program of the bash shell that we are actually executing. We are using to give this command. Now, what type is this file bash? So it is an executable. It's an executable file, and it also gives some other details that we don't understand right now, and we don't need to understand. If it is an executable, it is it is a binary executable file. It is a binary file. If we try to see its content with less, we will get some garbage. For example, let's try less. And even less is warning us, bash may be a binary file. See it anyway? Let's see it anyway. I type yes, and you see that we just get garbage. I type Q2. So this is how a binary file looks like if we try to read it. It is not understandable by us. We cannot understand it. It's not readable by human beings. Let's clear the screen. Now let's check the type of /etc. /etc is a directory. Since it is a directory, we can move to this directory. /etc. Actually, this etc contains the configuration files of Linux. So if a program needs a configuration file, usually it is stored on this directory or in a subdirectory of this directory. And usually configuration files in Linux are text files, so they are readable and also writable. We can edit them usually. This etc password is one of these configuration files. I'm listing its details with this command ls-l/etc/password. Let's check the type of this file. It is an ASCII text. ASCII text means it is readable. It is a text file, not a binary. So we can check its content with less. And actually, in this file password, it contains one line for each user account. in the Linux system. And in each line, it contains several information. For example, this is one account for user-Amir. This is one account for user one. This is one account for Andrew, for example, and it contains several fields for each account, fields with information. For example, this is the username. This should be the password, but actually it stores just X. The password is stored somewhere else. This is the user ID. This is the group ID. We will see user ID and group ID later, what they are. I guess this is an empty field that actually it should store some comment about the user or the name, the full name of the user. And this is the home directory of the user. And this is the shell that the user is using. So fields in this file are separated by this semicolon. Each field is separated by the other field by a semicolon. I press Q to exit from the less command. So let's go to the root directory again. Besides this directory bin, there is another directory which is named sbin. Sbin stands for system binary. So it contains, again, programs, binary files, but usually these programs are needed by the system itself, not by the users. So these are programs that are needed, are system related. So they are either used by an admin or by the system itself. For example, this command power off is to shut down the system, or file system check to check the file system, or for example, part add, partition editor to edit the partition, and so on. And some other binary files are stored in the directory user bin. We have seen this directory before as well. So this again contains some other binary programs, but why they are stored in user bin and not just in bin? Because these commands are not fundamental for the operating system, so they are additional, extra commands that are installed on the system. And there are also some binary files in user local bin. And now these are commands that are installed by the user, or so there are different binary commands stored in different directories. And in the root directory, we also see this directory boot. This boot contains files that are needed to boot up the system, like the kernel, the system, the system image, initial image, and so on, or the boot menu, etc. But in our case, it is empty because we are running in a Docker container, and Docker containers don't have their own kernel. They use the kernel of the host of the server. So in our case, we can't see anything inside because a Docker container does not need a kernel. Does not need to boot. In the directory dev, there are device files. Let's see what we have there. Device files are special types of files that are used for input and output, usually. For example, for each device of the computer, for the hard disk, for example, for the internet interface, there is a special file. There should be a special file in this directory, so that the system can access it, either to get some data or to output some data. And some of these device files that we will see are also std in, standard input, std out, standard output, and stdr, standard error. Std out, standard output, is usually the screen where the commands usually send their output by default. And by default, it is the screen. std in, standard input, usually is the keyboard. So where a program gets the input by default. And by default, it gets the input from the keyboard. And standard error is where a program sends error messages. So if there is some error, if there is an error during the execution of the program, it should output an error message, but where? And usually by default, it sends it to standard error. And standard error is again the screen by default. But we will see later, maybe on the next lesson, that we can also change the standard input, standard output, standard error of a program. And this TTY, for example, is the device that stands for the terminal itself. Let's check, for example, the type of this dev TTY. So it says character special and some numbers. So it is a special file, which is a character device. And I think that this dev PTS also is related to special files. For example, this is standard input, standard output, and standard error. And actually, if we check, if we see these are symbolic links. So file dev std in, it says it is a symbolic link to okay, prot self fd0. So it is a simple link to a file descriptor 0, file descriptor 1. Another important directory is home. As you can see, inside the directory home, there are home directories for each user. So there is a home directory for user -Amir, a home directory for user Andrew, and so on. So if I try to see the content of the home directory of user -Amir, it says cannot open directory, permission denied. Why permission denied? Because right now I am using the system as user 1, and users don't have access to the home directory of other users, usually by default. So it is to protect the files and the data of each user from the other users. This directory prots is also a special directory, a directory that contains some special files. And it contains some information about the system itself, about the kernel, the devices, the drivers, etc. So whatever information the system knows about this computer and about the processes that are running, etc., about the configuration of the kernel, we can see it and we can access it in the files in this subdirectory. And usually these files are read-only. We cannot write them. For example, I see this file CPU info here inside the directory prot. It is empty. Let's try with. It is a special file, but it has some content. It shows details about the CPU, the processor that is running in this system. So it is a genuine Intel CPU family, etc. The features of this processor. And since this processor has several cores, it is repeating these details for each core of the processor. So this, for example, this is the model of the processor of the server. I quit with Q. This directory var contains usually files that are changing constantly. For example, this var log contains log files of several programs that are installed. And log files are being constantly written from the programs. Programs append lines and information to log files constantly, so they are changing constantly. And that's why we store them in this directory variable. So the files in this directory usually are constantly changing. And another directory is directory TMP or temporary. So it contains temporary files. So if a program needs to create a temporary file, it usually creates it in this directory. If I reboot the system, the content of this directory is usually deleted, so it is not persistent. Let's check, for example, file TMP. It says directory and it has the sticky bit. Okay, we'll see what is the sticky bit later. Now we will move to another section of the commands. We will see some commands to change the structure of the directory or to move files and directories around, to create new files to rename them, etc. And the commands that we will use are cp for copy. It is a shortcut for copy. We will see the command mv, which is a shortcut for move. The command mkdir, which is make directory, and the command rm, which is remove, to remove files and directories, and the command ln, which is to create a link, either a symbolic link or a hard link. And we'll see how to use this command in an example, in an example scenario. So let's create an example directory. Make directory playground. I am in the directory root right now, and in the directory root I can read the content of the directory, but I cannot write. I cannot create files and directories. So I have to go to the home directory. To go to the home directory, I just type cd and press enter, or cd and tilde and press enter. So cd print working directory. Now I am at the home directory. Now let's try again the command make directory playground. We see that I have created this directory playground here. Let's go inside this directory. So I just type some letters from the beginning, for example, play, and then I press tab. When I press tab, it completes it automatically. If it is Unix, so there is no other directory that starts with play. So we created a directory with make the command mkdir, make directory. Now inside this directory we can create some other directories. So I'm telling create the directories dir1 and dir2. We see that these directories are created here. Now let's copy a file with using the command cp. First of all, the file is located here. So we have seen this file before. We know that it exists. And now I'm copying cp copy file, the full path of the file, and copy it here. So this dot means current directory. So copy this file to this current directory. So if I check with ls, I see the file password here. Now let's try again with the same command copy. I press the up arrows to get the previous command, cp etc password, and then dot. And now I press Ctrl A to go to the beginning of the command, Ctrl A. And then I'm adding this option -v. Now, what does this option do? What is it used for? It means verbose. Verbose means that it is telling what the command is doing. And in this case, it is giving this information message. So this file is copied to the current directory password. The Linux commands usually are terse. Terse means that they don't give lots of information. If you tell them do something, they just do it and don't give much information. But we can usually use this option -v to tell the command be verbose. Verbose means give some more information about the things that you are doing. Now let's try the same command. I press the up arrow, but with the option and then Control A, but with the option I. Now what is happening? The command cp is asking a question: overwrite this file, and I can press either yes or no. I'm pressing yes to override. So this -I is a shortcut for interactive. So it is an option that means be interactive. Interactive in this case for this command means if there is some operation that can possibly be harmful, can cause some damage, then ask for confirmation. Proceed with this operation or not. In this case, we have already a file password in the current directory. We are trying to copy another file with the same name in this directory, which will override the old file, the existing file. And this can be potentially destructive because maybe we have customized, maybe we have made some changes to this file. And that's why it is asking, it is being interactive, it is asking override, no, here, override this file, yes or no. Now let's see how to move files around directories and how to rename them. For example, I want to rename this file to a file with to have another name, and I can do it with mv. So I just renamed this file to this. So it is the same file, but the name is different. I changed the name of the file. This mv is for moving a file, but it can be used to rename it as well, because it says move the file with this name to the file with this name. So in this case, we are using it to rename the file. So there is no special command for rename in the Linux command line. We just use the command move. But the command move can also be used to move the file to another directory with the same name or with a different name. For example, let's say that we want to move this file fun inside the directory dir1. How do we do it? With the command move fun dir1. We see that it has been, it is not in at the current directory. And if we check the directory dir1, we see that it is already at the directory dir1. But let's use this command tree, which gives us a better view of the directory structure in the current directory and subdirectories. So we see that the file fun now is in the directory, inside the directory dir1. Let's say that we want to move this file from directory dir1 to directory dir2. How can we do it? We say move dir1 fun. So which file we want to move? We want to move the file fun, which is inside the directory dir1, and we are specifying dir1 with a relative path. So dir1 from the current directory. Move this file where? to the directory dir2. And we can also append a slash after the name of a directory, but even without a slash, it will recognize that this one is a directory and it is not a file. And it will just move this file inside this directory. So I did this. Now let's see the structure of the directories. We see that the file fun now is inside the directory dir2. And if we want to move it back to the current directory, we do it like this: move dir2 fun where to the current directory. So dot is the current directory. Now it is at the current directory. So we have seen how to move files from one directory to another using the command move. But we can also move directories. For example, I can move a directory dir2 to another place. For example, I can place it under directory dir1. And like this, move dir2 dir1. Let's see what we have. So the directory dir2 now is under the directory dir1. And to move it back to the current directory, we can do it like this: move dir1 dir2 to the current directory. So it is back to the current directory. Now let's see how to use the command ln to create symbolic links and hard links. Let's start first with hard links. And for example, with this command ln fun, it creates a hard link which is named fun hard. This hard link is for the file fun. And what is a hard link? Or let's create another hard link. For example,
Shumir,
yes, Anton.
I think Henry has lost the connection.
No problem. So we are recording it. Maybe he will.
Okay.
He will watch the recording. Maybe he has problems with the network connection.
Okay.
Okay. Now let's create a couple of other hard links. So create a hard link to this file, and this hard link is named dir1 fun hard. Let's create another one for the directory dir2. Let's see what we have. Now we see that we have this hard link, and this hard link, and all of them actually are the same file as this one. Now, to explain what is a hard link. A hard link is like another name for the same file. So let's say that the file is like a box with some information inside it. The file name is like a label on this box. So this box contains information, has a name. So it is like a name, it is like a label. When we create a hard link, we just put another label on this box. So it has a second name, but it is the same box, it has the same content. If we create a third hard link for the same file, then we just place a third label on this box. It has 3 names now, but it is the same box, it has the same content. If I, for example, edit the content of this file and then check the content of this file, I will notice that it contains the changes that I did, and vice versa. If I edit this file and then I open the content of this file, I will notice that it has the changes. So I will see the changes. I will see that it has changed. So actually, there are 4 names for the same file, and we can also kind of verify this with the command. So this command ls, this is long listing, and this is recursive. So it is making a long listing also for each subdirectory. We see this column here. Let's focus to the second column. It shows roughly how many names a file has, and we see that this file has the number 4. Also, this one is the number 4. Also, this one is the number 4. This means that this file has 4 different names because all of these are the same file. And for example, if I edit this file, let me try to edit it. I'm just adding a line at the top, exit. If I check the content of this file with less, for example, I will see that this file has changed as well. If I change the content of this file, for example, it is dir1 hub, I see that it is the same content. So these are just different names for the same file, for the same content. And if we list with the option I, so we are adding the option I to the command ls. In this case, the command ls is displaying another column of information here, and this is the inode. I think it is the number of the inode of the file. The inode is like the address of the file. From the inode, we have all the information. The inode contains all the information of the file. So where is the rest of the content of the file, the names of the files, etc. And we see that these files have the same address or the same inode, which means that actually they are the same file. So with hard link, we just create another name for the same file. Now let's see the symbolic links. To create a symbolic link, we use the command ls again, as before, but we add the option -s for symbolic link. The command ln to create a, so we use the command ln to create a symbolic link, but with the option -s. Now we see that we have created this new file, funsim, and it is a symbolic link to the file fun. Now, what is the difference between a symbolic link and a hard link? A symbolic link is like a shortcut for another file. So a symbolic link is another box. It contains another content, but the content of this file, so the content of this symbolic link, is the path to the other link. So it is like a shortcut. So a symbolic link is a new file, but the content of this file is a pointer to the other file. It is actually the path to the other. It contains the path to the other file. How we can reach the other file, starting from the symbolic link. For example, if we want to create a symbolic link inside the directory dir1 for the same file, for file fun, we would do it like this. So how do we understand this command? So this says create a symbolic link, and this is the file of the symbolic link. So we will create this file, and inside this file we will store the path to the other file, and the path in this case is /fun. Why /fun? Because this file will be created inside the directory dir1, and from this file we can reach the other file by following this path. Go to the parent directory and then go to the file. Let's create another symbolic link to the directory dir2. Again, we can from this file we can reach the content of the original file by going to the parent directory and then to the file fun. So in this case we are using relative paths to tell how to reach the original file. But we can use absolute paths as well. For example, we are in the directory home user1 playground, and the full path of this file is home user1 playground and fun. So this is the full path for this file, for the file fun. Now we can use the full path or the absolute path. Now we can use this one to tell how to reach this file. Home, user1, playground, fun. File exists. Okay, let me add the option F for force. So in this case, this is again a symbolic link to this file, but the content of this file contains the absolute path to reach this file. So we are reaching the file using the absolute path. Now, what is better? Are relative paths, using relative paths or using absolute paths? Sometimes it is better to use relative paths. Sometimes it is better to use absolute paths. For example, if I'm going to rename this directory, the current directory, or to move it to another location, then all the symbolic links that use a relative path like this one will still be valid. So the path will be still correct. But the absolute path will be broken because now the name of the directory is not playground, but it is something else. So this symbolic link, in this case, will be broken. And in some other cases, it may be better to use absolute paths for symbolic links. So especially if this file is not inside this directory, but it is somewhere else. So it doesn't matter whether I rename this directory, the symbolic link will still be okay, will still be correct. And why do we have hard links and symbolic links? Initially, the Linux system and the Unix system had only hard links, but hard links have some limitations. For example, with hard links, we can link only files, not directories. We cannot link to directories. And also with hard links, we can link only inside a device. We can not link a file that is in another device. And these limitations are overcome by symbolic links because all we have to store in the symbolic link is the path of the file, and it doesn't matter whether it is in another device and it doesn't matter whether it is a directory or a special special file and so on. So symbolic links are more flexible than hard links. And we can use, I told that, I just explained that symbolic links can be used for directories as well. We cannot use hard links for directories. For example, if I try to hard link directory dir1 to dir1c, hard link not allowed for directory. So I cannot link a directory. I cannot hard link a directory. But if I add the option S to make it a symbolic link, then we see that we have this symbolic link dir1 sim that actually is a pointer to dir1. Now, the last command that we are going to see is rm, remove. With this, we can remove files, directories, hard links, symbolic links, etc. For example, let's remove the file fun. And again, since I'm giving the option interactive, this -I is again interactive, and remove is a potentially destructive command. Not potentially, but it is a destructive command. So it is removing this file. And with the option -I, it is asking remove regular file find, and I can press yes or no. Yeah. And let's check now. We see now that all the symbolic links have changed the color, and this means that this symbolic link is broken. Broken means that this path does not exist anymore. This file does not exist anymore because I just removed it. But hard links don't have any problems because they are just another name on the same file. So I have just removed the name fun of the same file, but the file is not removed yet, actually, because there are these other hard links to it. For example, let's it is the same file unchanged. And I think that the time is almost over, but I'm almost finished. So a couple of minutes and we will close it for today. So we can remove hard links and symbolic links with the command rm. So in this case, it is not asking remove it or not because I did not pass the option -I. And we can remove a directory. For example, let's try to remove the directory dir1. But it is saying it is a directory. And since it is a directory, it has some content inside. So I can use the option R, remove recursively. This -R in this case means recursive. And recursive means that remove all the files and directories inside this directory first, and then remove the directory itself. And now we are done with testing. We can remove this directory playground itself. And sometimes we also add the option F to the command rm. And this means force. Force means don't ask yes or no. Just go and remove it. And we have removed everything. So this is for today, and we'll continue again on Friday. Do you have any questions? If there are no questions, then I will stop recording and close the lesson for today. Okay, let me stop recording.